Hello, everybody. My name is Laura. If you are new to the stream, welcome. But if you are old to the stream, welcome back. It's been a while and I haven't seen everybody before. Also, happy Halloween or day before Halloween. You can see that I'm quite blue today. And actually, the theme of my costume comes from this book, Hitchhiker's Guide to the Galaxy, which, for those in the know of the Prefect lifestyle, is basically the lore of Prefect. And I would like to tell you about an excerpt from page 39, where at the reveal of the Heart of Gold, there is a alien species there called the Huluvu, who are a super intelligent shade of blue. So that's what my costume is. That's what my hair's about. I did put Marvin very precariously. It's scotch tape, not even duct tape, so I'm not sure if it's gonna stay the whole time. I have backup tape just in case, but we're gonna try and keep him there, me here, as we go through the stream. So hopefully you all are wearing your costumes too. Also, hopefully they are Marvin inspired as well. But let me know if they are there or not. Let me show you all my screen. There we go. Because the topic today is supposed to be spooky, but hopefully by the end of this, you won't feel nearly as spooked about the concept of dealing with legacy data pipelines and trying to put them into Prefect. So there's a lot of folks who I think have a really great time with Prefect with something totally new. And then when they kind of go back to look at their legacy pipeline, they're like, I don't really want to move that, right? Or it's, I don't know, it's just like too much stuff. And also some of the things that you kind of need to set up, especially to make it work on such a modern platform as Prefect, like that is really sort of forward thinking about like being able to work with distributed computing or being able to work with Dask, is not necessarily immediately obvious when you're translating something that's from like a legacy standpoint. So this kind of came up for me because for the past month or two, I happened to be helping some friends converting their legacy pipelines into Prefect, and I felt like some of these things. So I think that that hopefully I can impart what I experienced to you, and you can try it out on your, I think on Twitter I said your ML pipelines under the bed or your ETL skeletons in the closet, right? So you can take those out. Okay, so basically what I've got set up here is kind of a couple general tips, and then I have two kind of demos to show you two different ways that I try to deal with some of these aspects. But to kind of start, just in general, of the things that I experienced while I was moving legacy pipelines into Prefect, is kind of step one is you need to decide what you're willing to spend your time on in terms of if you have stuff in other languages. Particularly, my example is going to be if you have a bunch of bash scripts that are maybe like the basis of your hidden cron jobs or something, right? Do you want to move that stuff into Python, or do you kind of want to not touch it that much, or do you want to be able to just orchestrate it the way that it is? So that's kind of going to be a decision point. And I kind of have two examples, one that's like kind of hands off here and is like, I don't want to change anything, and one that's a little bit more trying to move everything into Python. And the nice thing about doing that is you can leverage more Prefect stuff, right? You can use more benefits of Prefect if you break down your pipeline as is instead of just like smashing it in, but both are good. Big step that's going to have to happen, and in particular, I feel like the legacy ETLs or the legacy data science pipelines in particular might have a problem with this, is figuring out your dependencies. So especially if you're inheriting a pipeline that maybe was developed in like one data scientist or one engineer's like base Conda environment, then maybe it's not immediately clear to you what the code actually needs versus what actually, was in the environment at the time. So I've seen this happen several times. This is actually kind of like what I first experienced when I ever became a data engineer in the first place. So I think a lot of people can probably sympathize with this. If you are lucky enough to inherit a pipeline that already has requirements.txt or like pip lock files or something, then this should be a lot easier. But if not, I need to put a space here, but the classic like pip freeze conda list in the environment where this thing, whatever it is already running, is probably a good option, at least to get some basis. But I think as people who use pip freeze know, it's very exhaustive in everything that it lists and doesn't really tell you about the actual top level dependencies of your application. So I don't know if everybody knows about this, but there's this tool called pip dep tree that I have found useful in these situations. I'm just gonna kind of show you really quick over here. Pip dep tree, which is a tool that tries to do dependency resolution for you based on your pip packages that you have installed. So in my little environment here, I just have pip dep tree and Prefect basically, and I installed them, so I knew that they were the top level one. But you can see that it kind of like showcases that these are actually dependencies of this, as opposed to if I do a whole pip freeze, it's just like blah, the whole thing. And if you were walking into a virtual env or something on some, the one VM where this ETL has been running for 20 years or whatever, then if you just print out this might be a really long list that doesn't tell you anything useful at all. So that's kind of an aside, but pip dep tree has been useful in my forensic detective work in the past for legacy ETLs or data pipelines in general, so I would definitely recommend checking that out. And then it all falls down to literally reading the code at the end, right? So as much tools as we can get in here are great, but you'll probably also need to dip into the code at some point, especially if stuff is split between more than one language, or there's custom stuff that was like artisanally installed some other way, which is possible. So if something is from source or it just isn't on PyPI or whatever. So that's kind of like your last case. And this isn't instant, right? So just validating you all that this step might take a second. Not if you do figure out your dependencies, I would recommend that you build a Docker image from them and make sure that your scripts still run inside of them as is. So this is just to confirm that you can make this work at all. And in particular, though, you don't have to use Docker or any images to run stuff with Prefect. You can run it in sort of like your bare metal virtual environment, or you can make virtual environment on your EC2 instance or whatever. A lot of the power of Prefect, especially to get it very distributed, is going to be based on having this pre-packaged dependency thing that can go around on Kubernetes or on Fargate. So I would still recommend it. So we're gonna look a little bit at that, but that's kind of the falls out from the dependencies question. And just a couple other tips in here. I have a feeling that possibly many of your legacy ETLs are cron tabs running somewhere on some computer server somewhere, and nobody wants to shut them down, or at least that has been the case for me in the past. Definitely take a chance to analyze them, consider them as a basis for what sort of schedules you want to associate with your Prefect flows, right? I think that's kind of a no-brainer that how often they were running before is maybe how often or on what cadence you want them to run later. But I will say that I've seen a couple cases where there's some like overlap in the scripts that are running like maybe every 6 hours and then every like 9 hours and then 24 hours, and there's some stuff that's like common between them. So I wouldn't just wholesale take it. You may also consider that this is an opportunity to kind of refactor some of those dependencies so that they're more explicitly specified in your flow code, as opposed to just a property of the fact that these cron jobs run more or less after each other, which is sometimes what the people who were writing the cron tabs were leveraging, because that was the tools they had at the time. But now we have better stuff, so we can do stuff that's a little bit more explicit. And then down here is kind of like more the like meat and bones of trying to translate something that was in legacy code into Prefect. So we're gonna have to import Prefect at some point, right? So this pretty much starts out at how do we want to convert stuff into tasks. So again, I'm going to show you kind of two examples that showcase how far you want to take it. But there's definitely an opportunity here to use the shell task to just run whatever it is in the same cron tabby kind of way that you may have experienced before. If you have like a capstone Python script that you don't want to like peel apart beyond just, maybe just installing base conda somewhere, then that's totally fine. So in that case, maybe you want to use some sort of shell task, or maybe you want to upgrade a little bit and use a shell task that runs in your pre-baked Docker image instead of on your bare metal computer that you like artisanally installed everything in. But where we're really trying to go eventually here for stuff that's gotten to the point of being a pure Python task, whether that's a wrapper around something like calling something in the shell or is literally just pure Python code inside, then we're going to want to get that to be a task at some point, because then we can take advantage of everything that's going on in Prefect in the first place, right? Because then we can schedule our retries differently per task. We can change the way that where our results go per task. We can change the caching per task. All that stuff is per task. So the more tasks we have, the better Prefect can work for you. So that's the idea there. I'm going to showcase in my second demo this style of like progressively peeling off items to become tasks as you sort of feel like it. So this doesn't have to be an all or nothing kind of thing. You can kind of still have your big beefy like black box, even if you want that. Maybe you start peeling out a few things at a time. It doesn't have to be like everything has to be Prefect sized, like the smallest atomic task at the beginning. So don't worry about that. And then the two big things that keep coming up over and over is, how do I handle logging? And I need to deal with my Python path, okay? So particularly for handling logging, a lot of times I see the legacy stuff is coming from like a bunch of print statements, right? And maybe that was convenient at the time, or it's logging out like cron just like redirects out to some log file somewhere, and then somebody knows that that's where that is. And in our case, it would be nicer if we could use the real logging built into Prefect, either from the perspective of using Prefect Server, Prefect Cloud, and being able to look at the logs there, or just hooking in your own loggers using the Python logging module, which is what the Prefect logging is built on top of anyways. So, I'm going to show that a little bit. But that is often kind of like a whole sort of like grep replace type experience for people once they're done with their print statements. And then dealing with your Python path, Prefect is going to want to run your code from different environments, basically, from different paths, in the perspective of if it's your agent running it, if it's you running it on your command line, if it's like from the perspective of the flow runner, from the perspective of the task runner. So you kind of need to work it out between you and all of the ways that Prefect is going to try and call your actual Python code. So, my top tip, which is going to be in the second demo, is going to be to package your code up, like with the setup.py and everything, because this is kind of like the canonical general way. You don't need to publish it to PyPI. You can just install it as a dependency in your own Docker image and like live without needing to connect to any package registry. But you can use some Prefect configs to handle your Python path for you, depending on what your storage situation is. And then, I've seen it. People just fall back on sys.path and append, and just add a bunch of stuff in there, right? So hopefully we can avoid this by using these sort of more robust tools to be able to make sure that your Python is in the right place at the right time. But I've definitely, I've seen this in just legacy ETLs in general. Maybe you choose to leave it in it if you want. So those are the big tips in general. These are the things that I see. So I am going to show you my first little demo here. So let's get up my Sublime text, because this is what I think a legacy ETL looks like. I don't know if I should have like the scream track going or what, but you can imagine it. But here is a shell script that depends on some environment having already be set wherever this is, has some paths. I'm happening to make them randomly just for demo purposes, but has some paths kind of like hard coded in here. It has some, looping around, checking to see if some stuff exists, and then actually making folders and writing things down to disk. And then calling Python scripts that are also based on relative paths, just, in here in this file. And then also, using some other, not necessarily built into shell tooling that also assumes some environment that exists, some installed dependencies that exist wherever this is running, but at least they say, have a nice day, right? So this is kind of like what I've seen, the type of thing that I've seen. A little, this is contrived in the first place, and then also like slimmed down, but I feel like it kind of hit some of the points of the things that I have seen before. And in this case, there's also this directory called Python that has, manipulation.py, machine learning.py, do all the machine learning.py, right? And these are all sort of showcasing kind of like a patchwork way of how somebody may have put together a couple different tools and then thrown it all into a capstone script at the top that their shell script is going to call in the end, right? So here you can see it's expecting this to be called in a certain way with certain arguments in a certain pattern. This gets passed around. Again, we're depending on this DB name environment variable to be set everywhere that we are going. So this is the type of thing that could work great on the one machine that has been artisanally configured for, but it gets really scary to move into a new system or onto new infrastructure, and it just stagnates because people don't want to touch it, right? So this is my little example. So how I'm going to show you well, let's run it first for fun, right? Just to see the output. So in my jobs directory, I have this 24hours.sh thing, right? And I need to run this from the right environment myself, right? So this is already an experience, but I have here, this is a terminal where I'm using my Anaconda version of Python, and I've dropped in my base Conda environment. So this is like the kind of experience that I'm most commonly feeling from a dependencies perspective, where there's just, everything in here, everything that comes with Conda is in here. And I don't know what is actually a dependency of my program. And then if I do go run it though, stuff happens, right? And we can, it tells me to have a nice day. And you could probably look at this and be like, oh, great, I don't ever want to move this, right? Because I have no idea which of these are actually important. And it's telling me to have a nice day. So why don't I just leave it as it is, right? Okay. So this is the setup. So let me show you one way to sort of move it over to Prefect. And I have organized these into two different branches here, and I'm going to basically do an interactive rebase to show you how we can sort of build up on top of different Prefect features, taking us from this thing that we made. So let me get the Docker pipeline. There we go. Okay, so now I have over here a new version of this README with some highlights here of what I've changed. So this first demo, on the question of is there stuff I want to move to Python, my answer was no. I want to make minimal changes. So this is going to show you one way to do as little changes as possible, but still get this running with Prefect instead. Step 2, I had to figure out my dependencies. And in fact, since I wanted to really not change as much as possible, I'm still using the shell script. And in particular, my shell script is depending on specifically the ZSH flavor of bash. So I needed to make sure that whatever environment I'm running this in, I have ZSH, and that I also have all the Python dependencies that I expect. So in this case, I've put together a little requirements.txt. These are the two things that I depend on in my code, which I kind of knew because I wrote it. But also you could have figured out with like pip dep tree plus reading the code plus making some Docker images and testing it out, or different virtual environments. So that's what's going on there. And then the bash dependencies here and the actual install of these requirements.txt dependencies is actually happening in this Docker file. Let me make this a little bit bigger. So there's a couple things going on in here. This is inheriting from a Python 3.8 image, setting up some dependencies here in terms of this is installing ZSH, this is installing SQLite, which I learned is not already pre-installed for some reason here, and like the command line for my ZSH. And then here I'm doing this pre-step, which for my purposes, I'm using SQLite to kind of make it easier. In reality, you probably would be connecting, your legacy ETL is probably connecting to a remote database, so this is kind of not that important. But this is me just setting up the database as if it was the same as my local environment where this database is already set up. And then here I've got the step to copy in and install my requirements, and then copy in my actual shell script that I want to run, and then copy in all of my dependencies, my custom Python code dependencies here. So this is the big project basically that needs to be worked out, which I'll show some build steps too. But this is where all of that is actually going to go inside your Docker image. In my case, I'm building my Docker image from a Docker file because I used Docker before, and I don't know, I find it very comfortable, and this also gives me ultimate flexibility, but there are some Prefect ways to indicate how your image should be built without needing to write your own Docker file, so just FYI. Okay, then I'm going to show you this in a second from the beginning of this instead of from the end of this branch, but we'll want to build our Docker image. And then in my case, for the question for this demo, for the question of do I want to convert everything into tasks, my answer is no. I just want to run one Docker container that runs the shell script, and that's it. And I didn't have to touch anything, right? Nothing too serious. So this is kind of the like easier, or I don't know, it's just the less detailed version, less like hooking in Prefect part style, I guess. So I'm going to do a interactive rebase on my pre-cooked Docker pipeline start, and I'm going to use this to just make it easy for me to showcase to you the different steps. So basically, I'm going to walk us through setting up our external dependencies, which, spoiler, there's actually going to be internal code problems with that one, adding our custom code, and then I'll have environment problems, and then finally passing the environment to Docker to kind of like pull all of these pieces together. So here I've got my rebase actually changing, my Sublime text here of what we're actually seeing. So where I kind of started with this one was to get ZSH in here, get SQLite in here, install my requirements, get my shell script in here. Already was kind of tired, felt like I did a lot. And then if I come over to another terminal that I have handy, then I also have this flow, which is actually adapted from a flow that's in the docs, to just create a flow that creates a Docker container, starts it, gets its logs, waits for it to be done, nothing else, right? So the purpose of this demo is to just show if you don't want to do anything at all, right? So if I run this file, it has a flow.run at the bottom. So I'm going to go ahead and do that here just to show you that we've at least got some, prefect-y looking stuff coming out. But there's actually some problems with my situation right now. And actually, I skipped a step. Sorry. Let me show you one other point that I want to make, which is that since this whole thing is built on top of a Docker image, right? I need to actually build this Docker image, and then my flow here on line 12 depends on this image to exist. In this case, it's going to take it straight from my local build, but you could set it up to go find it from a registry if you pushed it to a registry. So I actually had a version of Spooky image from a future commit already on my computer, but let me rebuild the one that's based on this Docker file to show you the problem that we'll have here. So The way to do that here is I'm going to build my spooky image tag with the build context and Docker container that is in my current directory. So let's see, looks like this went good. And then I will run flow.py, python flow.py. Okay, cool. So this is actually the first error that I expected you to see, because this is what I mean by internal code problems in the commit for this one, which is that I've got far enough that it can do anything with these external dependencies, right, that I've determined. Like I know that I need pandas and scikit-learn, and I know that I need ZSH and SQLite, and I got all of that. But I'm missing my custom personal code, right? The do all the machine learning.py file, right? So this is where we need to include this in our environment somehow. And barring the setup.py pip install style, which I'll show you later, the super easiest way is to copy this code, right, into, and if we really want to do nothing, into a place where this relative path will still work, right? That is one up from where this is actually executing from, right? And then we will be in a situation where we made like the least amount of changes, but got somewhere, right? So this is what happens if we move past our last step. And you'll see this is where this actually shows up. This line 11 is the magic line here that copies everything from the environment I'm building my image from into this, whoops, don't mess it up though, into this location, which I know is going to work with this relative path, right? So it's just pure, like I'm following the rules of this bash script and not trying that hard. So I need to rebuild my image, right, with my new Docker file. So let's give that a go. You can see that it had all the old stuff and then this new copy python to /python location. So I got that in there. And if I run flow.py again, this is what you all saw before, I think, accidentally too early. But this is where now, even though we can run this file and find this file, like we're getting a trace back from actually running Python that is in this file, we have other problems, right? And this is where we have a problem because our bash script and therefore our Python script was depending on a environment variable being set that wasn't set as part of the bash script. It was like artisanally added by somebody in history. And this is kind of the runtime error that we see showing this to us, right? So this is where we need to deal with our environment somehow. And the way I'll show you that I did it in this case was in flow.py to pass in this environment as part of creating this container. So this is a way to, set up basically this secondary environment that's no longer my like artisanal VM or wherever this was, but my Docker container, to have everything it needs environment-wise to actually run the whole thing, right? So this is one way here. This is exposed in the create container task in the Prefect library to pass in this environment. And it takes either a dictionary or this like list of strings format from which gets passed to the Docker API underneath. But in any case, this is how we're actually going to set this environment variable now. And this way, we can run our flow and not have key error problems because our environment is actually set in there. So this is one technique, right? And this was just trying to do the minimal amount of stuff that I could get some other, Docker container going that had enough of the environment and had enough of the dependencies that it could go, and I didn't have to change too much of anything, and then I just smash it all into a flow that just creates this container and waits for it to be done, right? So this is one technique, and this is good for kind of like the first first pass. If you definitely need to get something off of your whatever bare VM that nobody has touched in a long time and we need to turn it down, or it needs to reboot, or like something is going on with it, and it's time to move, if you absolutely don't want to spend any more time than necessary to get it into a different framework and sort of set the stage up for yourself, then this is one way that you could go. So let's transition to the second demo here, which I have called More Flowy. All right, so more flowy. Let me get some more space on all my various terminals. So let me close some of these spoilers and then open up the sort of decorated README here for this one. So on the question for this new demo, on the question of what am I willing to spend the time to move to Python, this is a case of I'm going to move everything that I can. I'm going to try and leave that bash script behind, move everything into Python, potentially rewrite. In this case, I'm going to rewrite parts of the bash script in Python so that it's just really easy for me to use it as, just a pure Python function in this case. But there's definitely a spectrum here of how far that you want to take that, since you can still write shell tasks that call parts of your bash script if you want. But I'm going to try and do everything I can. And then in this case, because I'm not using my bash script anymore, I can throw out the fact that I need these ESH dependencies. I think I left it in my Docker file in reality, but I don't actually need them because I'm not going to run anything with shell. And then my Python dependencies may grow, especially based on the fact that I'm rewriting some stuff, right? So in my case, I think I only add in like requests, which is already in the standard library, so it kind of doesn't matter. But you could imagine if there was something new that you had to add in, a new third-party library, then you would need to update this, right? And in this case, I'm still going to make a Docker image. In this case, it's called Spooky Image Shiny. So that's my choice today. And down here to these questions, I'm going to use task decorators to change up my flow code so that it's not just one big container, that's one container task basically that's running, but there's individual tasks for each of the things that are actually logically happening in my flow, right? So that's what we're going to do there. And then I'm going to showcase kind of this development style through like the rebase commits that I'm going to layer on here of trying to just pull out like one thing at a time, using just pure Python techniques basically, but to smash everything into one mega task and then peel it out as I go. And then by the end, we're also going to see how the Prefect loggers work, and talk a little bit about the way to also export print statements with Prefect. And then I'm also going to package my code with a dead simple setup.py that I hope makes everybody who was ever afraid of writing a setup.py not be afraid of writing a setup.py, so that you don't have to, fight with your Python path anymore and let your pip or your package manager deal with it for you. So that's where we're going here. So let me rebase myself on what did I call this? More flowy start. And in this case, I'm going to showcase moving the bash stuff out into Python, right? Because I said I wanted to rewrite Python as much as possible. Start to take advantage of some of the Prefect things like parameterization, like parameters, oops, careful Marvin, and mapping, etc., to try and recreate some of the stuff I was doing in bash, but instead do it in a more Prefect way, and then deal with the logging situation. So let's do that. So I'm going to open up this manipulation.py and do all the machine learning here, and then also flow. So in this case, kind of like my first step here was to try and take the stuff that used to be in my used to be in my bash script and make it be in Python somehow, right? So there were kind of two steps to this. One is that I needed some sort of thing that was grabbing onto the Python that I already had, which happened to be in this do all the machine learning thing. That was like my capstone script, right? And then here, lines 8 through 10, here is me doing the sort of extract step which if we just briefly go back here to 24hours.sh, was actually happening in like my shell script here. Like I was curling stuff during a for loop, like a bash for loop. So I don't want to do that anymore. I want Python to do it for me. So instead of doing this, let's close that. Here's, pretty much like one-to-one from this perspective right now, turning this into Python instead of using bash. And in this case, I'm using a function I've described called extract, which is over here and just uses requests, right? So basically, requests is the equivalent more in Python of using curl and bash. So that was the idea here. So I just moved everything over here. Okay, so you'll see that do all the machine learning, whoever wrote it, it was me, but it doesn't even have a like if name equals main, it's just a script. But I can use this to my advantage here, I guess, advantage, disadvantage, but just importing it here is already going to execute all of that code. And this is just me pure, like I'm going to throw this in something I can put a task decorator on and then deal with peeling it out more later. So my actual flow is just going to call this flow pieces function, which is itself a task, which itself then just runs everything and do all the machine learning.py. So an important point here as well is that my Docker file has a new entry, new challenger, which is a pip install in the current directory, which in this case is me after I've gone into home, which if we back up all the way is going to install all of my dependencies here, my custom code dependencies, as a pip packet, like as a actual Python package, right? So that it's detectable on the Python path regardless of where I execute anything, because pip installed it in the right place. This is why we use pip, right? Instead of building stuff from source all the time and handling the paths ourselves. This is one of the reasons. So that is a big important change that has happened here. So the reason why this works is because A, I have a setup.py file, and B, it is in the directory above a package that, and by that I mean a directory that has a __init__.py, an init file in it. And if we take a quick look into setup.py, this is an example of kind of the like dead simple, easy setup.py. You can copy this and you can call yourself Huvulu too if you want, just so that you don't have to do a bunch of specialty setup.py stuff, just so that we can get our dependencies accessible regardless of where our flow runner or task runner is actually executing the code from. So in this case, the important parts is, this is mostly boilerplate. You'll see I gave it this name, Monster Mash. I copied this from setup.py's docs and deleted out some stuff that I thought was too much stuff. And then here, the setup tools.find packages, this is going to take the fact that setup.py is out here in the root, and there is a directory with an init.py file in it, which doesn't need to have anything in it at all. And it's going to determine that this directory needs to be a package, part of this Monster Mash package that I'm making, right? So those are the minimal least amount that we need to do. And that way we can, if I get out of here and get back to my setup.py, or rather my Docker file, then we can take advantage of these three pieces basically. And everywhere that we previously might have been, I guess in the bash script we were calling it by its actual file name, like relative path to where we were, we can instead, import it as a package, and it doesn't literally need to be in a sibling of wherever the Python path that we're running from. So one important point I want to make about setup.py is that I called my, package Monster Mash, but actually the package itself is named Python here. And that is why here you'll see python.blah blah blah as the package and the subpackage here or rather the module in there that I'm trying to actually use. So there's a divorce there, right, in terms of what metadata you're setting in setup.py and what your packages are actually named in the this dead simple base case. Just FYI, it was kind of painful for me to write Python here, but that's what the directory was called, and I was like, in reality, probably people would just leave it, right? So that's what's going on here. We're not secretly going into the Python internals. It's just my Python directory here. Okay, so this moves out some stuff here, but we still, it's only one task. It's this big flow pieces task, but at least we did the work of moving some stuff into Python that used to be in Bash. We have no more Bash dependencies anymore, and this can just now run there. So in this case, I'm also using f.register because I want to run this using server and using a Docker agent. So let me actually show you all of that. Hopefully some of you are server fans already. But let me make sure I'm in the right place here. Okay. And then I'm going to now run my flow.py. And what's happening here is that it's going to take my base image here, right? Spooky image shiny, which is also lining up with this here. Let me just give this a little bit more room so that everybody can see it, right? So I'm setting my flow up to have Docker storage, and I'm saying you need to store my flow in there in a Docker image that's based on spooky image shiny. And this local image equals true flag is what is also going to make it so that Prefect's Docker storage type doesn't actually go look in a registry, but instead just looks on my local computer because I'm just building them right here. So this is also reminding me that I should probably rebuild spooky image shiny, even though I had one before, just in case it was in the future. So let me do that step first. So over here on my very long terminal name, build, or Docker build, now I want to call it spooky image dash shiny, but still in the same directory because I've checked out my copy of my Docker file right now. So just making sure that I'm on the same commit here, and then I'm going to run flow.py. So this is important because my flow.py's Docker storage is based on this image that's locally built. I need to make sure I'm always using, the current version or the version that I want of my locally built image. In my case, I'm just using the latest tag, so I keep rebuilding it. But that's what's going on here. And then at the end of this, it's going to actually register my flow to server, and then I also have a Docker image on my computer right now that has all my dependencies from spooky image shiny and the actual flow itself in there. And this is the kind of independent atom that can move around anywhere. Right now I'm just going to run it on my local computer, but it could move around on different Kubernetes jobs. It could be the basis for your Dask image. It could be your Fargate task image, right? So this independently now can move around because it has all of the dependencies and the flow in it. That's the whole concept behind storage. So let's go check it out in my server that I have running back here. So now I have this new flow, my shiny new flow, right? And I can give it a run. It doesn't have any, parameters or anything. Hit run. And then I'm going to need a agent, right, to be able to pick up this flow. Right now it's just waiting, but it needs an agent to be polling to try to actually do this work. So let's do that in this terminal here. So Prefect agent start Docker is the order of words. And you'll see it immediately picks up my flow run. And you'll see here my failures, but this is also where you can see, for example, our schematic, where it's really just this one task, right? So it only does this one thing. So we can see what's up with our logs, what a surprise, we have environment issues, right? Because everything we did with our environment before, that was specific to that flow.py, to that container create task. We didn't make that like a general statement, I guess, for our next image. So we still need to figure out our environment stuff now in this other situation. So a couple options. It depends if it's actually like a secret, in which case you may want to use prefect secrets. But in my little example, I'm actually going to use a parameter to parameterize this using a default, and then also give myself the ability to change it in prefect server when I'm doing just ad hoc runs, right? So if I move forward in time here, we'll see that I have a change. Let's reload. Change here, which among other things, let me drop down here to line 27 before we get into everything else, is, or rather line 26, is to add a parameter that's going to actually set this DB name thing, right? In this case, it's my default value, which is what this environment variable has been this whole time, but in this case, it's a parameter. So I also have taken the liberty of taking everything that used to be in do all the machine learning.py and just copy paste it straight into flow.py instead of doing the weird import syntax, so that you can see what everything is. This way, we can register our flow again. In this case, I didn't make any changes to my Docker file, so I feel pretty confident that I don't need to rebuild my Docker file base image, but I am going to re-register my flow, which is going to rebuild the image that has the flow in it, right? Because I changed the flow itself. So it's going to be deriving from the same spooky image shiny, but all of this stuff mostly uses cache until it actually adds in my new copy of my flow. So now we can go check this one out, right? Which is just a revision on top of my prior one. So I also could have like breadcrumbed back and like refreshed, but I took the link. And now if I click this run here, you'll see that there's a parameter that I can set. So I could change this to something else. DB name is maybe not the most exciting thing to ever change, but that's what's going on here. So I can give this a run, start my agent again, and see how it goes. In this case, we've got green because we don't have environment problems anymore, and it so happens that was the last problem that I had, right, in this specific case. So the downside, as talked about before a little bit, is this is still just one big thing, right? We don't really have a lot of introspection into like what's failing unless we go find the tracebacks if there is an issue, and then we can't set anything like task level settings like retries or results, etc., caching on individual pieces. Like for example, maybe we would want to cache the extract step if we've already run it before. That was actually something that was already kind of a feature in the original bash script, because it checked to see if the data folder already existed for that random seed and then decided to proceed or not. That type of thing. To make that possible, we're going to need to take that extract step out so that we can put the prefect configuration on top of it. So let's move back into the future, right? And see an example of this, which the important part here is that we're going to take out, I copied the extract stuff that I had smashed into the top of my capstone here, and I took it out into its own function, and then I decorated that with a task. So now you can imagine you could throw in other task arguments here so that you could configure extract file names separately from the rest of what flow pieces does, right? So now this is a separate step in my flow, extract file names, and that actually gets passed into flow pieces, which then, continues and does everything else. So this is what I kind of mean by, as you're going through this process, you can kind of like peel like individual pieces out at a time. I found this to be the easiest way to develop everything instead of just like blank slate rewriting it for certain. So hopefully this kind of speaks to you a little bit too. All right, so let's see. I'm going to re-register my flow. I think this one's not that interesting because it still works. So we may proceed just to the next one so that we can get to the end. Okay, so yes, sorry. So kind of the next step that I thought was worth it was trying to get rid of some of these like for loops that are inside these tasks, because some of that I can actually make parallelizable if I utilize the fact that Prefect can parallelize stuff, across Dask or across different Kubernetes jobs or even Fargate tasks or whatever, as long as I use their mapping API, right? So if I can use their mapping API, then I can use the fact that they can widely distribute this for me, basically, and then I don't need to worry as much about the performance of my individual. This one's pretty contrived, but you could imagine that maybe this is something a bit more CPU intensive. So in that case, I've actually taken out this whole for loop iteration going on in here, and then just stripped it out just to the pure extract function that I had before. If we go over to manipulation.py, you'll see I've thrown on a task decorator on top of extract. And now I'm going to use mapping instead to map across, again, kind of contrived, but just my 3 numbers, right? And then I'm going to use the same URL. In this case, I also chose to parameterize my URL, but in the default case, it's this one. I set that to be unmapped because it's going to be the same for all 3 cases. So this is the way in mapping API that we can say URL is the same every time, but iterate through these, in this case, 3 numbers to make 3 different tasks. One that uses URL and the integer 1, one that uses our URL and the integer 2, and one that uses the URL and our integer 3, right? So this way we can use mapping. And we just had to recognize that there's some extra for loops going on in here, and that we could utilize mapping instead if we just got to the root of it. One important difference is that to get to this extract method or function, I need to import it not just inside my task function. You'll see that I kind of cheated here, and I've had all these imports underneath. So in this case, now I actually want to use extract directly. But to go get extract, I'm actually going to also import pandas at the top of this file. SQLite 3. Pandas is the one that's really going to hurt me here, because I happen to have been running all of these inside a environment that just had Prefect installed, a virtual environment that just had Prefect installed. So I didn't have to deal with the fact that the place where I'm building my flow and the place where my flow will actually be running need both dependencies if I'm going to be calling imports like this through the process of building my flow. So for example, if I try and run flow.py right now, it's going to say, what's pandas, right? Because I didn't install pandas here in this environment right here, but I am asking my flow.py to go import something that depends on that at actual runtime. So this is just this. I'm particularly bringing this up and also showed you the thrill of not needing to do it for a while, because I've seen people get frustrated because they just spent all this time getting their dependencies together, right, for their eventual runtime environment. Now we're just building flows, and we need them too, right? So it can feel a little jarring if you spend a bunch of time with that up front and now you need to do it again. The big important point is just that it depends what actually needs to be accessible, what needs to be importable in your flow at build time, at actual execution of Python flow.py. So in this case, I'm actually going to go out here into my another version of Python. This is my Anaconda version of Python, which has a bunch of stuff in it, just to, I need to be in the right directory though, up here. So in here is where my flow.py is, and then I'm going to hit here, flow.py, and then we don't get the angry where's pandas error, because pandas is actually installed in this environment in the case where I'm actually running with my Anaconda install of Python. And you could, make another virtual environment. I just didn't because I had Conda installed, but totally your choice. Okay, so that was a big point I wanted to make, and that's what I mean here by we now need a safe environment to build our flow from, right? We need a place that has at least the dependencies that are going to be imported here. Okay, so just in the last couple of minutes here to showcase a little bit about logging. So there is actually this really nice thing if you don't want to be too fancy about print statements. There's a task kwarg called log std out equals true, but it doesn't work if you're going to be calling other functions in here. If you had a bunch of print statements in here that said like, hello, this is great, I love blue, or whatever, then those would actually show up in your cloud logging and in your flow.run logging. But in this case, all of my print statements are actually like hidden, trapped inside all of these other things, so they're not going to show up. So in any case, what I would really recommend in reality is to actually use the logging module. In this case, it's in my case right now, I'm using the logger that already comes with Prefect, which you can get access to in your task through your context, prefect.context. And then once you get this thing called logger, it has methods on it, info, warning, etc., debug, to provide different levels of logging. So people who have used the logging module before in Python, it's the same thing, right? This isn't, it's just configured a little bit by Prefect for you so that it looks nice on cloud, etc. But it's just the same logger. You could also set up your own logger if you are familiar or have some other need for your logging to go somewhere else. But this is what I would actually recommend. So I actually peeled over the log that I got from my shell in the past, sorry, and just threw it in here as a logger.info instead, right? So this is the real deal of what I would recommend. So here I've made this change, in this flow pieces thing, which again, I haven't like fully pulled apart, but hopefully you could see that we could, peel out more of these pieces if we wanted to. And then also in manipulation.py, you'll see I threw in another call to grab my logger here. You'll need to grab the logger inside each task and then, call your logger methods as you want. So importantly too, you'll need, to be able to get to prefect.context directly. So you'll need to import prefect or prefect.context in any place that you're trying to use your logger from. But this is the real solution. And luckily print statements or print function, you can usually easily find with, grep or find and replace. I would definitely recommend, instead of like really tying yourself to print statements forever, though you certainly can with the std out log equals true if you want. But if you have the time to switch it out to logging, because you just have a lot more levels that you can use. You could configure your own logger, so it's just a lot more robust. Okay. And I think that is it. That is going through our spooky image shiny, moving things out of decorators, showing a little bit about how you can just smash everything into a big one and then peel it out piece by piece as you go. Doing a little bit of prefect loggers and showing you my dead simple setup.py so that you don't have to play games with your Python path if you don't want to. So that is the show. Hopefully it's made you less scared to handle your old pipelines. Maybe one other point I wanted to just say, particularly in the perspective of, seeing bash scripts like this, to me, I feel like a lot of these are really inspired by this book. I don't know if everybody has read it, but I find that I just understood a lot more of why I see so many legacy machine learning pipelines in particular, but other ETL pipelines written in Bash. Of course, Bash is used all the time, not just in data science, but I find a lot of inspiration in that book for me as a data engineer to understand how I want to move this into Python so that I can then use things like Prefect, right? And I can leverage everything about Prefect by moving things into Python and kind of leaving the shell stuff behind. But it's just a different way of doing it, right? If that works for you, that works for you for sure. And you can still squish it into Prefect if you want, using, for example, container create, using shell task, etc. So hopefully I've despooked some of it. And these were the things that I saw, helping my friends over the past month or so. And I'm sure there's more. I would love to hear, actually, if there's some specific thing that you have experienced pain when you were trying to move something, your skeleton in your closet or your monster under the bed into a Prefect pipeline. So feel free to let us know. Hit us up on Slack. We can chat it out, and maybe we can do another version of this. I don't think Halloween is, I think we could probably get some more content before next Halloween for that one, so we don't need to wait that long, but we can still all wear costumes. I'm still willing to do that. So also, hopefully you enjoyed. Marvin made it the whole way. So thank you everybody for stopping by, and I will see you online later. Bye.